Hi, just a quick video to show how to use a ruler and compass to do constructions of triangles and angles and so on. So let's just share my screen and we'll go straight into the whiteboard. Here we go. This is open board, which I sometimes use because it's got a ruler and compass and a few other tools as well, which are quite useful for this sort of thing. So here's the first question that we're going to work through. Here's a sketch of a triangle. In the space below, use a ruler and compasses to construct this triangle accurately. You must show all construction lines. So therefore, yeah, so that's what we want to draw. So let's just get a ruler out. And so we'll start off and just draw the base of the triangle. So we are looking for the length of 6.3 as the base of this triangle. So let's just draw this line, 6.3. All right. Move that away. Okay, so now we want to point up here, which is 5.7 centimeters from the bottom left and 4.2 from the top right. So how do we do that? Use our compass. And so let's start with a 5.7. So if we set this, you can see that on the scale there, 5.7, that's what we've got there. And so we put one point at that end there. Let's just move it up. It's going to be around about here. So let's just draw ourselves an arc here. There we go. So all the points on that arc there are 5.7 from the bottom left. Now we'll do the same thing with the bottom right. This time we want 4.2. So let's just adjust that, 4.9, 4.4, 4.2. There you go. And swing that around about there. And we draw that arc. These are the construction lines that they're asking you to leave in. And so there we go. So this point here, we know this is on this arc, so it's 5.7 from the bottom left, and it's also on that arc, so it must be 4.2 from the bottom right. So all we need to do now is draw in our lines and get that one right. The thing. Get that out, and then so there we go. So that line is 5.7, and this line is 4.2. So that is it. We've done it. All the angles will correspond as well. If the lengths of the sides are the same, then the triangles are congruent, and therefore all the angles are the same as well. So that's what we've got there. Right. Okay. Let's look at the next one. Now it goes on to say. Use the ruler and compasses to construct the perpendicular to the line segment AB that passes through the point P. Now this is in addressing this, what we've got to kind of understand about is a geometrical shape called the rhombus. You may have come across a rhombus. Is basically it's a four-sided figure with all sides the same length, and but not all the angles aren't right angles necessarily. So it's a bit like a squash dip. You can imagine a square, and you sort of push it a bit, it shears over a bit, and that is basically a rhombus. So we're going to draw a rhombus around here, and then I'll explain how that's actually helped us. So what we need to do first of all is we need to look at this, the length of this line AP, and project the line further along here. So we get a point up here, so that P is therefore in the middle of that line. So let's get our ruler back. There we go. So now I'm looking at the length of this. Try and get it exactly right. Yeah, so this length here from A to P, it's just under the ruler there, where the X is, that looks like 7.5. So if we extend this line up here, to another, so it's another 7.5 past P. Then now, bit awkward to draw with his tool, to be honest, so I've not quite got it right at this end. But there we go. So AP and then P2, we can call it what we want to see up here or something. Then AP is the same as PC. Right, so now this is where we're going to use our there. Now we want a length. It doesn't actually really matter exactly. We're going to with this slight variation on you know on our rhombus, but around about there. So that's what's 9.1. Let's make it 9.0. Round bigger. Okay, so so what we're going to do, I'm going to draw an arc now. Yeah, and now I'm going to come and do the same thing down here. Okay, so from A to these arcs, any point on the arc is going to be 9. Right, I'm going to come here to C. I'm not marking it. That is C. And we're going to do same thing. There. So, so from A to the to that arc is 9. From C to that arc is 9. So this point here is 9 away from both A and C, and similarly with this one down here. So let's just mark the side of this rhombus in. And I think, as you can see, it is just what I said, a squashed in square, because this angle here, this angle here is less than the right angle, isn't it? It would be about 75 degrees or something like that. And then this one would be therefore 105 degrees. So so that is that. Now the useful properties of rhombus. Let's just draw this diagonal in, which lo and behold goes through P. Now the useful properties are that first of all these diagonals, they well, they not only bisect each other, which means that that this one cuts this one in half and this one cuts this one in half. Oops. But they basically do it at right angles. So that, and that are all 90 degrees. So this is a very useful useful property. So how does it relate back to the question? Use the rule and compasses to construct the perpendicular to the line segment AB that passes through the point P. Well, that's exactly what we've done. This line goes through P. And we know that P is the midpoint of this AC. I never wrote it in there, C up here. That is the so basically, because this diagonal bisects AC, then P must be in the middle, and also, of course, they bisect at right angles. That is a right angle for all right angles. So we've done that one. That's good. Right. Let's have a look at the next one. We're going to look at the moment. Use a ruler and compasses to construct the bisector of angle PQR. Okay, well, I think I can already say that the diagonals bisect the bisect the angles. So let's just draw another rhombus, and hopefully that's going to do the trick for us. So what we're going to do, let's set this to 9.0. That looks like a convenient figure. Right, so what I'm going to do is I'm going to mark the point along QP, which is 9 centimeters away from Q, and then we're going to and then we're going to do the same thing down here. Right. So now, if we oh dear, lost my measurement. There we go. That's fine. Right. So so staying on 9 centimeters. And we're going to mark an arc there. And then we're going to mark an arc there. Right, so then let me just fill in the lines, because the way we've built this, we know now that this is a rhombus. It's got all sides of equal length, 9 centimeters. So therefore, when we draw in the diagonals, and of course these bisect each other at right angles, but not only that, but they also bisect the angle. So this diagonal bisects this angle P here. So this is the same as that, not the same as that, not the same as that. Most importantly, from our point of view, is that that is the same as that. Use the ruler and compasses to construct the bisector of angle P, Q, R, and it says you must show construction lines. Well, we've got them all on here, these straight lines and these arcs and so on. So that is it. Now there are a set of questions that you may get at GCSE, which are things to do, right? You're designing a garden and you want to place a bush that's you want to make it no more than 5 meters away from the pond and no less than 4 meters away from the shed or something like that. So those come up, and very often if you're doing scale diagrams, then using a compass is the ideal way of doing that, because we can set our meter to the whatever the scale is to represent 5 meters and 4 meters and so on. Draw our arcs when we can see the areas that satisfy the criteria. But we're not looking at that kind of question just now. This is really just to get the idea of using the compass, the compasses, and also the idea of the rhombus, which comes into quite a lot of these problems. So I think we'll just stop there. Hope it's been useful, and I'll see you next time.